Hello everyone, I am Ramakrishna, working as Assistant Professor in the CSC department at VIGNAna JYOTHI Institute of Engineering and Technology. So in the previous video, we have discussed about the UML diagrams. One is use case diagram and second one is class diagram. After the use case and class diagram, then we are going to discuss in this video about interaction diagrams. So interaction diagrams there are two diagrams comes under this category. One is sequence diagram, second one is collaboration diagram. So user will interact with the system completely at this level. So that's why it is named it as interaction diagrams. Here you are going to show the clearly step-by-step process. Like in the previous videos, we have discussed use case diagram. In that, you are going to show the behavior of a system. So how it is behaving, that you're going to capture the main use cases, that is main functionalities. Also in this another video we have discussed about the class diagram. There you are showing its functionalities as a class. Under that you have shown it as function or method. Then once the functionality is identified, then you are going to describe clearly about each functionality. Suppose you take an example of ATM machine. So what is the purpose of ATM machine? First main important functionality is you're withdrawing money. So how it will be done? So that will be represented clearly step by step with the help of sequence and collaboration diagrams. So these two diagrams are call it as combined name is interaction diagrams. So it is helping the model how objects interact in a system and how the messages, how it is exchanging, that is each objects, how it is exchanging, that will be shown dynamically. So in the previous video, we have discussed all the UML diagrams are divided mainly into two categories, structural diagrams and behavioral diagrams. So here, these interaction diagrams comes under behavioral diagrams. So here, this is used for system analysis part, design part, and also will be used for testing part under the software development life cycle. So coming to the sequence diagram, what it is showing how objects interact over time. So it is purely focusing on the flow of control by time ordered messages. Coming to the collaboration diagram, it is showing how objects are related and exchanging messages. It is concentrating on the flow of control by organization. So what it contains? Common properties are interaction diagrams share common properties with other diagrams, and they consist of, again, just like the class diagram or use case diagram, here it is consists of a name and a graphical representation to describe the model. What it consists exactly? It consists of objects and links and messages. So also along with these main elements, we always include the few more elements like notes and constraints for additional details. So if you see this pictures left side and right side, so here it is showing clearly so how it is interacting, what exactly is doing. So the step-by-step process you are showing clearly, so that you are representing with the help of each shot in the picture. So what is the shot number 32 by E, what is the shot number 32 by F and G and H. So based on that will be interconnected and the flow of control will be showing with the help of interaction diagram, that is sequence diagram. Why? Because these shots will be merged at the time of editing a picture, editing a movie. So for that there is a need of each shot number clearly, you should mention it clearly, then only it is possible. And because you should follow the time order also, because based on the screenshots which are available on the screen left side and right side, so which screen should come first and which one is next, likewise that will be arranged orderly based on this short numbers and based on the time. So in this way you are going to edit, the editors will edit the movie completely, so based on this numbering. So in the same way, in our software application, we'll use the sequence number. So based on the sequence number, we can able to identify how it is interacting each object under the system and how it is exchanging the messages, and that will be connected and that will be shown easily. So here, if you see this, so storyboards, if you take the storyboard, it will show you the visual representation of each scene in the sequence order, and based on that sketch and based on that order, based on that, we'll map everything and we'll connect the each scene by using the sequence number, and we'll prepare a complete video. So here, that frames and shots are very important. Here the frames are calling it as a sequence diagram. Why? Because that frame order must be followed, and shots is, when it comes to shots, it is collaboration diagram. So how you are organizing it, you want to play it in a sequence way or you want to play it in a different way. Like nowadays everybody is like showing the final climax scene, they'll show in the first scene itself, and the interval comes later. So again the last scene will be maybe sometimes the backdrop scene. So likewise they will change the order to show the curiosity to the about the film or about the scenes to the customer. So here, sorry, to the audience. So here, based on that, we'll prepare. So this sequence diagram, like a storyboard, captures how messages flow over time, and a collaboration diagram is like a group shot that will shows the relationships between the multiple entities in a single frame. Under the same frame, there will be like different emotions, different persons have the dialogues. So that will be merged under a single scene. So they will capture differently, but later they will organize together and making it as a single shot. So likewise they will do it with the help of objects and messages. So with the, in filmmaking, actors are objects. They will interact by delivering the dialogues and actions like messages. So in this interaction diagram, so system components are objects that will interact by sending and receiving the message. So that will show you the importance of the behavior, system behavior. And if you see this, just like the previous diagrams, again here also object will be declared. So like this. So first that is called it as a named instance. Second one is called it as an anonymous instance. If it is like interacting with more than one object, that is called multi-object. And if it is not interacting with any other object, it is a separate one, then it is called orphan instance, you can call it as. So likewise, there are different types of objects we have. You know that the object is a real world entity. So this is going to represent, it consists of data attributes and its behavior. That means its method it is showing. So an instance is a specific realization of an object. So this is going to indicate the clearly instance. So how you are indicating means it is underline. So this underline means because the object and class both are graphically looks like same. How you need to differentiate means here simply you are doing with the help of underline. So it is, if it is underlined, it is called object. And multi-object sometimes like represents the multiple instances of a class. If you are representing more than one class, or if you are representing the like more than one object, then we'll go with this multi-object concept. Then the links you are showing in this particular category, this is called as collaboration diagram. Collaboration diagram is focusing only the flow of control by organization. So how it is connecting, that you are showing, and these are the numbers order, and this is the stereotype you are using. Create is the stereotype, global is another stereotype, local. Why? Because while declaring any attribute or any function, so you are clearly specifying it, like whether it is you are going to use it within the main function or within the class only, or outside class or the outside area you are using. So the based on that we'll declare it as whether it is local variable or global variable. Also also when to create and when to destroy, that you are doing with the help of constructor and destructor. Wherever there is a need, there itself you can create the object, and once it is usage is done, again you can destroy that object. Also you can have extra properties like a transient object, like I want to mention it clearly, this type of object, and I want to mention clearly like its arguments, whatever the arguments you are passing, that everything you are showing clearly with the help of sequence. So in this way you are representing the collaboration diagram. And this is the sequence diagram. So this is the way you are taking. So first we'll have the objects, and this is the representation called, this dotted line representer is called timelines, and this is called it as flow of control. Whenever one object is interacting with another object, when it starts exchanging the messages, that flow of control will be shown with the help of this rectangle box, and these are the timelines. So for every object we'll create the timelines. So based on that we'll start exchanging the messages. Once the operation is over, we'll indicate like this by using cross mark. This is called destroy. That means I have stopped using this particular object, and you are sending the messages here like this. This is called object message, and for every message, if you want, you can represent the reply message also like this. So because of this, you will these type of things are called as synchronous messages. Like for every message you are expecting the acknowledgement. Sometimes if you don't want to represent for every message, you don't want to represent reply, then you simply that it call it as a asynchronous message. Only you are sending the message and you are not showing the replies. So all these. So this is the collaboration diagram. So this is the way you are representing everything. This is time ordered messages you are representing, and this is only the flow of control by organization. While sending all these things, we are using some stereotypes like call, return, send, create, destroy. All these stereotypes will help to what type of message you are exchanging among these particular objects. And here clearly you are showing the stereotypes. He is the actor, he is the controller, this is the UI. So likewise you are showing, and you are going to stop the operation here with the help of destroy, with the help of a graphical symbol cross mark, and whenever you want to create, you are doing like this. So this is the way you are representing. See this, the representation, all the four objects are started at this place, only this object started at this place. This is the concept called, with the help of constructor and destructor, whenever there is a need of that object, there itself you can create the object like this, and once it is done, then you can destroy the object like this. So this is the speciality. No need of creating everything at the beginning, and no need of wasting the time or a memory also to save all these things. So in this way you are doing, and this is called it as time ordered messages. This is the way you are representing. And for these key parts here, generally we'll mention clearly if it is object means. So likewise you are doing underline for this, and also you are showing clearly if it is like multi-object, or if it is more orphan object, or it is having the path instance you are showing. So everything you can specify it clearly under the objects. And here I told you just now, if you want to send a message synchronous manner or asynchronous manner. Synchronous means you are expecting the reply like this. This is the way you are giving the reply. Asynchronous means you are not expecting any response, only just you are sending the message like this. And here all these things you are doing clearly, so with the help of each and every element clearly. So this is the way you are providing everything, all the methods, its attributes. So this is the way you can have pass the arguments also and to the function. So So these are the examples. So for interaction diagrams, like step-by-step execution you are doing with the help of sequence numbers, and always we'll start with the actor first, then we'll go with the remaining components. So we'll start exchanging the messages with the help of object message. So there are two types of communication. One is a straight communication object message. Another one is message to self. Two ways you can do it. Suppose database object or class is available. Suppose you just want to check the pin number whenever you enter the pin number of your ATM card. Then here you can just like give like this. Just it is checking the pin number, self message. So in this way you can represent it. And here for this collaboration diagram also, it is also same like sequence diagram. The only difference is there you are showing the flow of control and timelines. In this collaboration diagram, you are not showing those two because you are not following the time order. You are only concentrating on the way you are organizing these particular objects and their interconnections. So that you are showing, and you are indicating this execution order based on this numbering. Also you have a subsequence like 2.1, 2.2.3, based on that will go. And here we'll apply some stereotypes, we'll apply methods with arguments, all these things you can have. So different types of objects, if you want multi-object, orphan object also you can add here. So this is the way you are representing. Also it is showing the message direction and what type of message you are passing, that you are clearly showing here. So based on that, we'll execute this particular step-by-step process. And in the last video we have discussed, after discussing the each and every diagram, then we'll discuss about the CMT's common modeling technique. So in these interaction diagrams we have modeling flows of control by organization, and also we have a modeling flows of control by time ordered messages. Modeling flows of control by organization means it is about the collaboration diagram. Here you can represent like this. So in this, if you want like this, you can represent a message to self, like it is checking. Also you are clearly showing its constraints also, when it is resisted, yes or not, true or false, that is clearly showing. So every parameter, every attribute you are adding clearly, its constraints, its values, everything will be specified clearly to that particular class or object here. And here you are not following the time order, that is with the help of flow of control. So directly whatever the messages exchanged between, suppose these two classes are there, student and register agent. So only two messages have exchanged between these two. One is create, second one is register. So that you are directly showing clearly. And likewise we will represent. So because of representing like this, it will be easy to identify what it is sharing and what messages are exchanging these two classes, that you can represent clearly. And there are some differences between the sequence diagram and collaboration diagram. So one is like focusing. So sequence diagram is focusing on the message flow over time between the objects. But when it comes to collaboration diagram, it is focusing on the object relationship and interaction, but not on time. Coming to the structure. So it is arranging the vertically with objects in the top and messages flowing downward. But here if you see, these objects are arranged spatially with links showing association between them. So here we are time representation. If you check here, it is time is explicitly represented as messages are arranged sequentially. One step by step sequential order will follow. But here when it comes to this, it will not follow. It will only follow based on the labeling and based on the sequence number. It is time is implicit. And coming to the message representation, here we are using arrows. Based on that, you are showing the order of execution. Here when it comes to this, messages are labeled. So here we are using sequence numbers, links and all those. With the help of these, you are going to check the represent the communication between objects. And coming to the next one, best used for. So sequence diagram is best for modeling the workflows, method execution, and understanding message order. If you want to know the message order, then definitely go with a sequence diagram. Otherwise, you can simply go with the collaboration diagram, because it is easy to understand the object relationship, because there is no clumsy, so it is easy to identify the relationships and also how different the components are interacted, that you can see it clearly in the collaboration diagram. And coming to the complexity, definitely sequence diagram also, it is easier to understand because of the linear flow. So there is no confusion, there is an order, based on that you can go. And when it comes to collaboration diagram, it can become little bit complex due to multiple links, because with between the two objects there are so many messages have exchanged. So you will get some confusion while checking that links and everything, all those messages. Otherwise, this is also good. And finally, the UML representation. Here we are using the lifelines, active bars, arrows, and everything. So represent the object interactions over time. And here also we are using the objects, links, and all along with that numbered messages you are using. And this we are using to represent the communication structure. So this is the way, coming to the common modeling techniques under the interaction diagrams. So two are mainly we are modeling. One is modeling flow of control by organization, that is collaboration diagram. Second one is modeling flow of control by time ordered messages, that is sequence diagram. And these two you are doing under the interaction diagrams. And at the end of the each diagram, we are also going to discuss forward and reverse engineering like class diagram. So here also you are doing the constructing the code from the model, whatever the objects you have declared and how they are exchanging the messages, all those we are trying to convert, but may or may not be able to convert 100%, but there is a chance of converting into code from model, that is 80% or 70% is possible, even for forward engineering and for reverse engineering also. But when it comes to reverse engineering, forward engineering will generate more, because it is possible, it is easy. Why? Because this particular UML is taking the support from the C++, Java, or C# object oriented languages. Then it is easy to convert the code from the model in forward engineering. So that's all about the interaction diagrams. In the next video, we'll discuss about the remaining diagrams. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.